In this video, we'll look at graphing a piecewise function that involves a quadratic, a linear function, and in some cases, a constant function. In this example, we have f of x equals negative x squared plus 10 if x is greater than or equal to negative 4 and less than positive 4. And f of x equals 6 minus 3x if x is greater than or equal to 4. So for the first part, I know that this is going to be a parabola because I have a quadratic. So I want to first go ahead and find the vertex of that parabola. If you recall from previous sections, the vertex happens when x equals negative b over 2a. Now, in this quadratic, my a is negative 1 because I have the negative x squared. There's no x term, so b would be 0. And then c is 10. So because b is 0, the x value of the vertex will be 0. The y value we always get by plugging in the x value of the vertex. So I'll get negative 0 squared plus 10, which is just 10. So my vertex happens at the point 0, 10. Now I want to get one other point. So for another point, let me just move one spot out from that x value. So let's say, for example, x equals 1. Then y would equal negative 1 squared plus 10. And negative 1 plus 10 gives me a 9. So I would have the point 1, 9. So that's going to help me with graphing. And now let me figure out the endpoints. So when I say the endpoints, I mean at the endpoints of that given part of the domain. So when x is negative 4 and x is positive 4. So when x is negative 4, I'll have y equals negative, parentheses, negative 4 squared plus 10. That's going to give me negative 16 plus 10. So that would give me a negative 6. So I'll have the point negative 4, negative 6. And then I'll have x equals positive 4 for my other endpoint. And I'll have y equals negative, and then 4 squared plus 10. 4 squared is 16, so I get negative 16 plus 10, so negative 6. So my endpoint on the right side will be a positive 4, negative 6. So now I'm ready to graph the parabola part. I'm going to start with the vertex, which was at 0, 10. I'm going to plot that second point, the 1, 9. And I know that a parabola is symmetric about the vertex, so about that axis of symmetry. So I'm going to go ahead and plot a point on the left side of the vertex as well at negative 1, 9. The end point is at negative 4, negative 6. So I'll go ahead and plot that point. It's going to be a solid filled in dot because of that x greater than or equal to negative 4. So that's going to be a solid dot. Now the one that corresponds to x strictly less than 4, that's going to be an open dot. And so at the point positive 4, negative 6, I'll have an open dot. And I have a parabola, so I'll do my best to just kind of sketch that in and make it end up in the right spot. Nope, didn't quite get it. Okay, so here we are. There we go. And we're just doing our best to make it end up at that end point. Okay, so there's my parabola part. Now I want to graph the linear part. I haven't done anything with this yet. So 6 minus 3x, if x is greater than or equal to 4. So what I want to do with this part is I want to start by finding the value when x equals 4. So when x equals 4, I'll have y equals 6 minus 3 times 4. So that will be 6 minus 12, which gives me a negative 6. So I have the point 4, negative 6. And because of that, x greater than or equal to, that's going to be a filled in dot. So I'm going to come back to the dot that I did not fill in for the parabola at 4, negative 6, and I'm going to fill it in. The second point that I'm going to find is going to be based on my slope. My slope, if you look at that line, is negative 3. And so that tells me that from that point, I'm going to go down 3 because it's negative, and I'm going to go to the right 1. So rise over run, down 3 to the right 1. So I go down 1, 2, 3, and to the right 1. And so I'm going to have a line now that goes like that. And so this will be my graph. It's part parabola, part line. We have a filled in dot over here at the point negative 4, negative 6. And we have a filled in dot at 4, negative 6 because of the second part of my piecewise function. Now, let me show you how to use the tool in ALEKS. Here I have a piecewise function where y equals 8 if x is less than negative 4, y equals negative 10 plus x squared if x is greater than or equal to negative 4 and less than positive 4, and y equals 2x minus 2 if x is greater than or equal to 4. So let me focus on this constant part first. If x is less than 4, less than negative 4, then y equals 8. So I'm going to select this ray here. I'm going to go to negative 4, positive 8. And a constant function is just a horizontal line. So I'm going to click another point to the left of x equals negative 4 where y equals 8. Now notice that this is a strictly less than, so I'm going to do the hollow dot and put it at the end of that segment. All right, I'm done with the first piece. Y equals 8 if x is less than negative 4. Now I want the parabola part. So I have no bx term in this quadratic, and so b is 0. So my vertex is going to happen when x is 0, y would have to be -10. So I'm going to have a vertex of 0, -10. So I select parabola. I'm going to go to 0, -10. You have to choose whether the parabola opens upward or downward. And I have a positive x squared, so it's going to open upward. So I just click up above the vertex. Then it says place another point. I'm just going to pick an x value of 1. And so I get -10 plus 1 is -9. So I'm going to have the point 1, -9. And now here's the tricky part about graphing it in ALEX. I have to use the cutting tool to get rid of the parts of the parabola I don't want. So I have to figure out what's happening at the endpoints. So if I plug in a -4 for x, -4 squared is a positive 16. So -10 plus 16 is 6. So I'm going to have the point -4, -4, positive 6. So I select the cutting tool. I'll put in -4, positive 6, plot point to edit graph. And then I select the eraser and erase the portion of the parabola that's to the left of that. All right, now the right endpoint, when x is positive 4, I would get -10 plus 16, so a -6. So I'm going to do the cutting tool at positive 4, -6. I'm sorry, positive 4, positive 6, because 16 plus -10 is positive 6. So 4, 6, plot point to edit graph. Grab the eraser and erase the part of the parabola that's to the right of that endpoint. Now you look at filled in versus hollow dots. So when x is -4, I have the x greater than or equal to, so that will be a solid dot at the point -4, 6. And at the point positive 4, 6, I'm going to have a hollow dot because it's a strictly less than. All right, now I'm on the third part of my piecewise function. Y equals 2x minus 2 if x is greater than or equal to 4. So if I plug a 4 into here, I get 2 times 4 is 8. Minus 2 is 6. So I'm going to have the point 4, 6. And then I have a slope of 2. So I'm going to select the line tool. I'm going to go at 4, 6. And then a slope of 2 is going to be up 2 over 1. And actually, I should have selected the ray tool. Let me undo that and select the ray tool. I'll start at the point 4, 6 with a slope of 2, so up 2 over 1. And now because of that x greater than or equal to 4, I have to fill in a solid dot at the point 4, 6. Now, because of this gap here, at x equals -4, my function is not continuous. So I would say no, it's not continuous. So that is my graph. I'll do another example in a separate video in case you need more with this graphing tool in ALEX.